Okay, let's talk about section 2.2. Graphs of equations in two variables, intercepts, symmetry. Okay, so first, graph equations by plotting points. Okay, so we have equation. Equation can have many variables. So in this section we only talk about equation with two variables, in two variables. Two variable, you can call it st, uv, wy, whatever, but usually we call it x and y. Okay, and an equation is a statement in which two expressions involving x and y are equal. Two expressions involving just with x, y are equal. Okay, so you definitely have some equality. It's not inequality, it's equality. Okay, and for example, something about here, x, y, blah, 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 is equal to something about x, y in the right side. So the expressions are called the sides. So this is the left-hand side, this is right-hand side. When we talk about the side, it is with respect to the equal sign, right? And for example, you have x squared plus y squared is equal to 1. That's one. This one is an equation. It's not function, it's an equation. Any values of x and y that result in a true statement are said to satisfy the equation. Satisfy the equation. For example, x squared plus y squared equal to 1. This is the equation. And we can see that when x is 1, y is equal to 0. This equation is true. The left side is equal to the right side. So we say the x equal to 1, y equal to 0. Satisfy the equation. Of course, here you may have many possibilities. For example, you can also get x equal to -1, y equal to 0, or x equal to 0, y equal to 1, or x equal to 0, y equal to -1, or even more complex like x equal to square root of 2 over 2, y is equal to square root of 2 over 2. You check that this also satisfy the equation. An equation may have a lot of satisfaction. Okay. When we have so many pairs of numbers, satisfying the equation, we're going to put them together. It's like the solution set. Okay, so the graph of an equation in two variables, so we only talk about two variables, x and y, consists of the set of points in the xy plane. So let me finish it. Whose coordinates x and y satisfy the equation. Okay, so what does this mean? This means, you see here, this is a pair of numbers. This is another pair of number, another pair of number. So there are several pairs of numbers, maybe more. And for each pair, you have a corresponding point in xy plane. For example, we first draw the xy plane, and 1, -1, 1, -1. And 1x, okay, so 1x is 1, y is 1. It corresponds to the point here. X is equal to 1, y is equal to 0. Y equal to 0, my bad. 1x is -1, y is equal to 0. It's here. X is equal to 0, y is equal to 1 is here. X is equal to 0, y equal to -1 is here. And also x is square root of 2 over 2, y is square root of 2 over 2 is possibly here. Okay? And if you find more pairs satisfying the equation, you're going to label them. Once you can get all the points with the coordinates satisfying the equation, you just get the total set of the points with the coordinate satisfy the equation. You plot them together, it will be called the graph of the equation. Okay? It will be the graph of the equation. So the graph of equation just means whenever you have a point here, you say, okay, I have a point x0, y0 on the graph, then it means this x0, y0 should satisfy the equation. You plug in x0 here, or y0 here, the sum of square is equal to 1. So that's the graph. Okay. So let's see first example. Determine if the following points are on the graph of the equation 2x minus y equal to 6. We are going to determine if some point is on the graph or not. A, point 23. Again, the point on the graph where it have the coordinate satisfying the equation. Now we are going to check if this pair of coordinates satisfy the equation or not. So here x is equal to 2, y equal to 3. Let's compute two sides. The right side is 6, you don't have to compute. So basically you just compute the left side. So it's 2 times 2 minus 3. It's 4 minus 3 is equal to 1. The left-hand side is 1, and right-hand side is 6. It is not equal to 6. So when you have this pair of values, you get a false statement. It's wrong. It's not equal. It's inequality. Okay? So the point 2, 3 is not on the graph. It's not on the graph. Okay, you just check it because it's not equal to 6. It's not equal to the right hand side. It's not on the graph. And second, let's check another point. Another point, we also get x equal to 2, but y is equal to negative 2. In this case, let's evaluate the left hand side. It's 2 times 2 minus negative 2. So 2 times 2 is 4, minus negative 2 is plus 2, it's 6. Okay, so it is, okay, this 6 comes from the evaluation of left hand side. This 6 comes from the right, sorry, not here. It comes from the right hand side of the equation. Okay, so they're really equal to each other. So the point 2, negative 2 is on the graph. Right? So to verify or to check if a point is on the graph or not, just plug in the coordinates, plug the coordinate into the equation to see if you satisfy the equation or not. All right. So that's it. And this one is a simple equation. You can quickly determine if a point is on the graph or not. And second, let's try to graph some simple equation. Graph the equation. Y is equal to 2x plus 5. How do we graph the equation? We just try to find all possible pairs of x and y satisfying the equation. Try to find as many as you can. And after certain examples, we want to determine the pattern behind those samples. Okay? So here, 2x plus 5. Let's check. For example, we can choose x equal to 0. When x is equal to 0, the right-hand side becomes 2 times 0 plus 5 is 5. So y must be 5 in order to satisfy the equation. And then you check x equal to 1. X is 1. 2 times 1 is 2 plus 5 is 7. So y must be 7. X equal to negative 1. Negative 1. 2 times negative 1 is negative 2. Plus 5 is 3. X is 2. X is 2. 2 times 2, 4 plus 5 is 9. X is negative 2. X is negative 2. You got 2 times negative 2, negative 4. Negative 4 plus 5, 1. Okay, so let's try to plot. You see here, y has the largest value 9. So 3, 6, 9. Okay, so 1, 2, 4, 5, 7, 8. This is 9. And x we select 0 plus minus 1 plus minus 2. So 0 is here, plus minus 1 plus minus 2. I don't have big paper, so we have to shrink the unit. Okay, so when x is 0, y is 5. X is 0, 1, 2, 3, 4, 5. Y is 5 here, this point. When x is 1, y is 7. X is 1. 1, 2, 3, 4, 5, 6, 7. 7 is here. When x is negative 1, y 3. 1, 2, 3 is here. When x is negative 2, y is 1. Okay, 1. When x is 2, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you're not so sure about the graph, you can get more point. The reason we choose those integers because it's easy to evaluate. Here we can also choose x equal to 1/2 because 1/2 times 2 is 1 plus 5 is 6. So you choose x as 1/2, y is 6. X is negative 1/2, y is 4. Of course, you are not going to choose x equal to pi or stuff because that's difficult for us to evaluate, right? So 1/2 is 6, negative 1/2 is 4. So then you try to connect them. After the connection, you realize it possibly it is a straight line. Okay, so the graph, that's the graph of the function. The graph of function is going to be a straight line through all these points. Okay, so you use seven sample points to try to determine the graph. When you connect those lines, because you have no any idea, so you are not going to connect them by the crazy curve. You just use straight segment to connect them, and then you see it looks like this. Okay, so that's a graph of y equal to 2x plus 5. And in order to determine the x, y values, usually we just set x be one value and try to get the y value. So here, when we set x to be 0, we compute, we determine the y. We don't just randomly say x0, y0, is this a point on the graph? No, we don't do that. We just set one, find the other one. Okay, so let's try the other. Example, graph the equation. Y is equal to x squared. Okay, so we're going to do the similar stuff. We'll choose x equal to 0, 0 squared is 0. X is equal to 1, 1 squared is 1. X is equal to negative 1, negative 1 squared is 1. X is equal to 2, 2 squared is 4. X equal to negative 2, negative 2 squared is 4. And also, if you want some smaller number, x is 1/2, 1/2 squared, 1 over 4. X is negative 1/2, negative 1/2 squared is also 1 over 4. Okay, so let's see. Y has the largest value 4 so far based on our sample point. Okay, so 1, 2, negative 1, negative 2, 1, 2, 3, 4. When x is 0, y is 0. This is 1 point. X is 1, y is 1 is here. X is negative 1, y is 1 is here. X is 2, y is 4 is here. X is negative 2, y is negative 4. Y is still 4, sorry. It's here. Okay? It looks like a V shape, but it's not a straight segment because when x is 1/2, y is 1 over 4. 1 over 4 is very low. It's half of 1/2. When x is negative 1/2, y is 1 over 4. So that's all 6 sample point. If you want, you can get more sample point. After you get more sample point, you will see the graph is really like the V shape, but it's not connected by the straight segment. It's a little bit curved, a little bit curved. So this is a graph y equal to x squared based on plotting. Okay, these are the graph. Okay, so at this moment, we only evaluate or we only look for the sample point from the equations and try to connect those sample points by the smooth curve. Sometimes a straight segment, sometimes just smoothly connect them. Okay, don't randomly wave or stuffs. Okay, so if you don't have any other ideas, then this is the only way for us to determine the graph. But later we will see other technique to sketch the graph. But so far, you just get sample point and plot them. Okay, that's a first part. Graph the equations with two variables. Whenever you graph equations with two variables, it is going to be a curve in the xy plane. Okay, for us, for our simple graph, of a simple function. And second, we are going to study some properties of the graphs. So find intercepts from a graph. So after we get the basic concept, we are going to study the properties. So first, we're talking about intercepts. What is intercepts? The points, if any, may have one or more. The points, if any, at which a graph crosses or touches the coordinate axis are called the intercepts. Okay, crosses or touch the coordinate axis are called intercepts. Okay, so for example, in the textbook, it gives the graph like this. So this is called a touch. The graph is on one side of the x-axis is touch. Here, this is called cross, from one side to the other side. This is cross. This is also cross. So based on the current graph, this graph has four intercepts. 1, 2, 3, 4. They are all intercepts. Okay. These 3 points, the graph crosses or touch the x-axis. They are called the x-intercept. Those values are called x-intercept. And this point, the graph cross or touch the y-axis is called a y-intercept. Okay, so let's see. The x-coordinate of a point at which the graph crosses or touches the x-axis is an x-intercept. Okay, so for example, this point, at this point, the graph touches x-axis. When you touch the x-axis, this point has x-coordinate x0. Y-coordinate is always 0. X-axis, on the x-axis, all the point has y-coordinate 0. So this is not interesting. This x0 is a useful characters, the numbers for the graph. So this x-coordinate of the point, we're talking about this point. We're talking about this number. X-coordinate of the point at which the graph touches the x-axis is an x-intercept. So this number, this is x-intercept. Intercept is a number. It's not a point. It's x-coordinate of the corresponding point is a number. Okay, and similarly, the y-coordinate, this is x-intercept. This is also x-intercept. This x0, x1, x2, they are all x-intercept. They're just numbers. The corresponding one is a y-intercept. The y-coordinate of a point at which the graph crosses or touches the y-axis is a y-intercept. See here, this one. At this point, the graph crosses a y-coordinate. So the x-coordinates is always 0. Then you get the y-coordinate. This number is called the y-intercept. Okay, it's called the y-intercept. So for the current graph, the function has 3 x-intercepts and 1 y-intercept. 3 x-intercept and 1 y-intercept. Okay? So if you have the graph, you can quickly determine the x and the y-intercepts. And remember that intercepts are always numbers. They are not points. They are the corresponding coordinate for the intersection point. Okay. Okay, now let's see the example. Find the intercept of the graph in the figure. What are its x-intercept? What are its y-intercept? Okay, so the graph looks like this. The graph looks like this. Here, this touch, this point, this is -3, 0. Here is 0, 3. Here is the coordinate is 3/2, 2, 0, 3/2, 0. Here is this coordinate is 0, -4/3. Here is 0, -7/2. Here this is 9/2 and 0. Okay, so be careful about the writing. What are the intercepts? Intercepts are points. It has coordinates, 2 coordinates. X and Y intercepts are numbers. So the intercepts of the graph are what? Let's see. -3, 0. This is 1 point. And 0, 3. 3/2, 2. 0, -4/3. 0, -7/2. And 9/2, 0. So just follow the curve and see all the intersection points. So the intercepts are points. They have x and y coordinates. And the x-intercept, the x-intercepts are just, you see, -3 and 3/2 and 9/2. They are numbers. They are the x-coordinate of the intercepts with the x-axis. Okay, so -3, 3/2 and 9/2. The y-intercept on the y-coordinate. So 3, -4/3, -7/2. Okay, so this is a y-intercept. You follow the y-axis and read the y-coordinate. Okay. So if you have the graph of function, you just read the graph and find the corresponding coordinates. Just be careful about the difference between the intercepts and x-intercepts and y-intercepts. Intercepts a point, it has x and y coordinate. X and y intercepts are numbers. X-intercept only has x coordinate. Y-intercept only has y coordinate. Okay. But sometimes you do not have the graph directly. You only have the equation. So how do we find intercept? From an equation. Okay. So to find the equation, let's see how we get it. So you see here, intercepts actually can be read from the x-y intercepts. So intercepts, they are either from the x-intercept with y-coordinate 0 or from y-intercept with x-coordinate 0. Okay? X-intercept together with 0, so -3, 0, 3/2, 0, and 9/2, 0. They provide those three intercepts. Y-intercept, you get 0, 3, 0, -4/3, 0, -7/2. They get the other intercepts. So if we can find x and y intercepts, we can determine the intercepts also. We can determine the intercept. So we are going to have the following strategy. So it's a procedure for finding intercept. The first one, we're going to find x-intercept. To find the x-intercept, if any, you see x-intercept has a property that the y-coordinate must be 0. Okay, x-intercept has a property y-coordinate must be 0. So of the graph, we're trying to find the x-intercept of the graph of an equation we just let y be 0 in the equation and solve for x. X is real, where x is a real number. We're talking about real number all the time, except in the section of quadratic equations. We may use complex numbers. Other than that, all the xy's are real. Okay? So second step, to find the y-intercept, if any, of the graph of an equation, we will let x be 0, y-intercept or x coordinates are 0 in the equation, and solve for y, where y is a real number. Okay, the same parallel steps. All right. So for x-intercept, y is 0. For y-intercept, x is 0. So let's see how we get it. So the example, find the x-intercept and the y-intercept of the graph of the equation y is equal to x squared minus 4. Then graph y equal to x squared minus 4 by plotting points. Okay, so now let's see. To find x-intercept, so we're talking about the x, so we just let y be 0, make y vanish. Y is 0, so let's see. In the equation, so you get a 0 is equal to x squared minus 4. Remember, 4 is 2 squared, so x squared minus 2 squared. We know that a squared minus b squared is a minus b, a plus b. So 0 is x minus 2 and x plus 2. Okay, we factor it. After factor it, we use zero product properties. We get either x minus 2 is 0 or x plus 2 is 0. So here you get x is equal to 2 or x is equal to negative 2. After you solve this equation, you find the precise value for x. So the graph has two x-intercept. 2 x-intercept, 2 and the negative 2. 2 and the negative 2. You have two solutions, 2 x-intercept. See? In order to find x-intercept, you let y be 0 and solve for x. You get the answers. The number of answers will be the number of x-intercept. Parallelly, to find y-intercept, we're going to let x vanish. X is 0. So y is 0 squared minus 4 is negative 4. So you only have one answer. So the y-intercept is negative 4. That's it. That is it. All right. Let's try to graph. We're not done. We only find x and y-intercept. We have to graph it. Graph it. We use sample point. So x is 0. We already compute y is negative 4. X is 1. Here x is 1. 1 squared is 1 minus 4 is negative 3. X is negative 1. Y is also negative 3. X is 2. Y is 2 squared minus 4 is 0. Y is negative 2. I'm sorry, not y. X is negative 2. Y is also 0. So if you want, you can examine more. So when x is 3, 3 squared is 9. 9 minus 4 is 5. So y is 5. Y-x is negative 3. Y is also 5. 1, 2, 3, 4, 5. 3, negative 3. So when x is 0, y is negative 4. Here's negative 4. 1, 2, 3, 4, negative 4. X is 1, y is negative 3. X is negative 1, y is negative 3. X is 2, y is 0. X is negative 2, y is 0. X is 3, y is 5. X is negative 3, y is also 5. So it looks like this, right? So that is the graph of the function y equal to x squared minus 4. The x-intercept here and the y-intercept is here. So it's 2 minus 2 minus 4. See it? So this is how we find the intercepts, basically x, y intercepts from the equation. X-intercept, y0, y-intercept, x0, solve the equation. And the other way. So sometimes we want to see other properties about the graph. Here, this property is about the graph interaction with the axis, x-axis, y-axis interception. Other property is like the mirror property, symmetry. For example, if you stand in front of the mirror, you will see an image. The image is exactly you, but you are symmetric. You are here, your image is their place. Okay? So in the plane, assume this vertical line is an image, vertical y-axis is image. Here is the x. Here its image will be negative x. Right? Here is a xy. This place it will be negative x and y. Correct? Because this is image, so it's balanced. Y, x, negative x. Here is x and y. Then if you balance it about the y-axis, for example, assume this is surface of the lake, then its image will be, this is y. It will be negative y. So it will be x and negative y. You're about the symmetry vertically. Right? Okay. So we have the following definition. It will use those observations. It's a test, an equation for symmetry. With respect to the x-axis, the y-axis, and the origin. Okay, so what is a symmetric with respect to x-axis? Like this. This piece on top is identical to the piece on bottom. In other words, if you fold this page along the x-axis, those two pieces coincide. We say they are symmetric. Coincide means x, y on the top, then x negative y will be on the bottom. Right? So the definition. A graph is said to be symmetric with respect to the x-axis if for any point x, y on the graph, for any point x, y on the graph, like this point is on the graph, then its image should be also on the corresponding part, right? The point x negative y is also on the graph. This is on the top branch, this is on the bottom branch, but together they form the whole graph. Correct? It's a symmetric with respect to the x-axis. X-axis, you're on the top, then the image is on the bottom. The image is x negative y, so the x negative y point is also on the graph. Right? So let's see the example. For example, if a graph is symmetric with respect to the x-axis and the point 3, 2 is on the graph, then the point, okay, so check here, 3, 2 on the graph, then the point 3, negative 2 is also on the graph. 3, negative 2 is also on the graph. So it's this picture. It's this picture. Okay, so it's the symmetry about x-axis. Whenever you talk about symmetry, it must be with respect to certain lines, certain surfaces. Okay, so this is about the symmetry with respect to a certain line. It can be symmetric with respect to the x-axis. It can also be symmetric with respect to the y-axis. Okay, so the definition: a graph is said to be symmetric with respect to the, okay, I think I missed it. Oh, x-axis. Yeah, here, my bad, I missed this. Y-axis. If for any point x, y on the graph, the point, okay, see, this time we're not going to check here. What? Let me draw it here this way. This is x, y. Its a symmetric image is negative x and y. So you're going to fold the graph along the y-axis. Okay, so here's x, y. X, y is on the graph, then the corresponding image, negative x, y, is also on the graph. Okay, then this is a symmetric with respect to y-axis. Symmetric with respect to y-axis. So, for example, 5, 8 is on the graph. It would directly imply negative 5, 8 is on the graph. Okay, this time you put the negative sign for the x-axis, x coordinate. For the x coordinate, that's because the symmetry is about the y-axis. Symmetry about the x-axis, x does not change. Symmetry about the y-axis, y does not change. Okay. Okay, so that's about the x-axis, about the y-axis. And another thing is about the symmetry about a point, for example. This is x and y. If we're talking about the symmetry about a point, it means this is a midpoint, the origin, about the origin. It is a midpoint. Midpoint, you will see that the corresponding symmetric image must be negative x, negative y. Remember the midpoint formula, 0, the x coordinate should be x plus negative x. Remember that? You have x1, y1, and x2, y2. Then the midpoint M has coordinate x1 plus x2 over 2, y1 plus y2 over 2. This is a midpoint formula. Here, for these 2 points, the midpoint x plus negative x is 0, over 2 is still 0, y plus negative y is 0, over 2 is still 0. So the midpoint is the origin, right? So that's exactly the symmetric point with respect to the origin. So when we talk about a graph symmetric with respect to the origin, we're going to use this point. Definition: a graph is said to be symmetric with respect to the origin if for any point xy on the graph, the point negative x negative y is also on the graph. Okay, so you can check this way, let's see. For this way, you see here, if you have a point here, you go the straight segment, go to the opposite way. So these 2 points are symmetric. If you have such way, it is symmetric with respect to the origin. How do we geometrically realize it? You have this branch, you rotate it pi radian, or you rotate it 180 degrees, you get the other part. This time is about the rotation. Okay, if you get the symmetry about the line, it's you fold it. Symmetry about the line, you are going to fold it. You fold it along y-axis, it's symmetric about the y-axis. If you fold it along x-axis, it's symmetric about x-axis. And if you have a symmetry about a point, you're going to do the rotation 180 degrees. Okay? So x, y, and the negative x, negative y both belong to the point. So that belong to the graph. Then this is a symmetric with respect to origin. So for example, 4, 2 is on the graph. It will imply negative 4, negative 2 is on the graph. Negative 2, negative 4 is on the graph. Okay, so let's try. There is a, okay, so we're going to discuss example in the next video. Okay, we finish this video. Thank you.